Doing complex roto and compositing is all about continuity, so broken frames can really cause issues, but harnessing specifically trained machine learning models, FrameFixer ML will help you fix flashes, artifacts or dropped frames. But it can also be used to speed up much more complicated tasks. I'm Christoph Zapletal for Boris Effects. Let's take a close look at FrameFixer ML inside of Boris Effects Silhouette. In this shot, we've got a lot of flashes hitting our talent from both left and right. Our task is to get rid of those flashes to make the scene moodier. Let's insert a FrameFixer ML node into our node tree. The controls do offer us different workflows and we will explore each one. For starters, let's define two values: the frame to fix and the duration for which it needs to be fixed onwards. The first flash occurs on frame 27. If we jump through our clip frame by frame using the Z and X hotkeys, we can see that the flash starts on frame 27, but then moves higher on frame 28 before disappearing on frame 29. So on frame 27, we will activate the stopwatch icon. That way we can put down multiple keyframes for frames we want to fix, because, as you've seen, we've got quite a number of flashes in this sequence to get rid of. We did set down a keyframe for a flash on frame 27. But rather than setting down another keyframe on frame 28, let's tell Silhouette that it should fix the issue on frame 27 for a duration of 2 frames. To do that, we will set our repair duration to 2. That way Silhouette will achieve a nice interpolation between the last good frame, 26, and the first good frame afterwards, 29. Let's take a look. That looks quite nice. Especially on our talent's code, you can see that the detailed pattern stays intact. Using methods like optical flow or tracking patches would require more manual cleanup, but this looks pretty good out of the box. We've got flashes on frames 39, 64 and 75, so by hitting the F button we can quickly add those frames in there as long as we've got keyframing activated. The next flash is here on frame 87, but if we shuttle through our sequence we can now see that the result is not so great. Looking at our original footage we can see that the flash is actually 3 frames long. So let's hit the watch icon on our repair timer as well. That way we can fix this flash properly for a duration of 3 frames. The next flash is on frame 107 and that one is once again 2 frames long, as are all the consecutive flashes. Let's quickly drop in those remaining keyframes. Now let's take a look at our timeline. If we open up the graph for our keyframes, we can see that they are all set to hold. That is by design, so that FrameFixer ML will only process the frames that actually need fixing. That will not only keep your processing times manageable, but also avoid unwanted artifacts on frames that never needed fixing to begin with. But let's use FrameFixer ML for something a little bit more elaborate. Our scene already looks moodier, but our talent closing his eyes here does take away the impact. Let's fix that. I already pre-rendered our clip so that we don't do any repetitive processing on the flash removal. To get rid of the closing of the eyes, I need to set my repair duration to 42 frames, starting at frame 153. The problem is that there's a lot going on in those 42 frames. The camera is moving and the talent is also pulling up his shoulder. So performing just the FrameFixer ML alone will result in a little bit of a mess. Luckily, Silhouette is a node-based system and FrameFixer ML a node that we can basically put anywhere. Let's help Silhouette along by stabilizing the face first. We can do it quick track inside the Mocha Pro module, tracking only translation, rotation and scale, and making sure to have holdout mats for the talent's eyes in place. With the track done, we can go back into Silhouette and call up a transform node. If we pipe in our plate and the data from the Mocha Pro node, we can choose the head layer we just tracked to stabilize our image. While we are at it, let's create a second transform node and pipe in our stabilized result, and of course also the tracking data from the Mocha Pro node. Choosing the same head layer as before, but this time setting it to match move instead of stabilize. Good! Now we can work on the stabilized image between the two transform nodes and be sure that the motion will be correctly reapplied once we are done. 42 frames of repair is a lot to process, so let's help Silhouette along even more with the DOD node, where we put the domain of definition around our talent's eyes with some ample margin. This will greatly reduce the number of pixels to be analyzed and processed. So now we can insert a fresh FrameFixer ML node right here. This time, as we've got one long range to fix instead of several individual frames, I will select the Ranges option from the drop-down menu and define the range I want FrameFixer ML to fix. Great! Now we basically get a machine learning powered seamless transition for the whole duration our talent closes his eyes. Let's also add a swap channels node to ensure we have a black, e.g. transparent alpha. Now we can insert a roto node and apply a soft mask around his eyes before the movement is reintroduced by the second transform node. All that's left to do is to use a composite node to bring it back on top of our plate. But you can also combine FrameFixer ML with the paint tools of Silhouette. In this shot, we want to get rid of the falling snow, but keep the reflections intact. Let's call up a paint node and hook both its image and its data output up to FrameFixer ML. The data output will supply FrameFixer ML automatically with the information on which frames we actually did some paint work. That is also the reason why our option to set up bad frames or ranges are grayed out once the data input is connected. To achieve a convincing result, it is best to keep the distance between the frames short. Also, consistency in your paintwork is really key. But as you can see, with just a couple of painted keyframes, FrameFixer ML takes care of the bulk work for us by morphing between the individual painted frames. In this example, I'm using the continuous mode, which will make a continuous transition from one painted frame to the next. In pairs mode, it is possible to set up painted frames as pairs to have individual morphs between them. To learn more about these modes and the ability to morph your paint strokes using a power mesh, check out our tutorial on Power Mesh Morph inside of Silhouette. FrameFixer ML is just one of many great AI-powered tools inside of Silhouette that can really speed up your workflow, so be sure to check out our other tutorials on boriseffects.com. I'm Christoph Zapletal for Boris Effects, and I will see you in another video.